Hello, everyone, and welcome to today's Learn With Us session on Team Cymru's community services. I'm going to pass it straight over to James Shank, who's going to introduce himself and go through the presentation. So thank you very much, and I'll see you all at the end. Thanks, James, over to you.
Thanks, Michelle, and thanks to UTRS for having us. So today I want to talk to you about Team Cymru's community services and the power of what can be accomplished through community cooperation. And a little bit about me, just to get started. I'm James Shank. I'm the Chief Architect of Community Services at Team Cymru, and I'm also a Senior Security Evangelist. So you put those two things together and it basically means I'm a nerd that can talk to people. I've been at Team Cymru for about 12.5 years now, and in my role at Team Cymru currently, I am involved in making no-cost solutions to internet scale problems, and you'll see some of that today in what these solutions that I'm talking about today look like and what they accomplish. A quick agenda. So today I want to talk about cooperation and the internet, and that'll be a little bit of a kind of a fun or a story that I enjoy about the history of the internet, DDoS and cooperation, network threats and cooperation, and then a quick overview of some of our community services that focus on a number of different areas involved in internet safety and internet security. So I've always been fascinated by the history of the internet, and one of the things that strikes me about the history of the internet is how much cooperation took place to get things started and then to continue to propagate the internet. This story here is one that I really, really enjoy. It talks about some of the first, in fact, I think it is the first message ever sent from one city to another over the internet, or the early days of the internet, I guess. This was computer-based communication, one of the first messages sent between computers. And it's a fun story because at the time, they're just getting started with some modem-like communication devices. It involved something like about 8 or 9 different companies and several universities and many other people and many other operators that were involved in getting this message sent. And as they're sending the message, they're on the phone talking to each other as well. And on one side, they send an L character and they say, "Do you see an L?" And yes, I got the L. And then they see an O character, and then they send the O character, and then, "Do you see the O?" Yes, I got the O. And then when they type the G character, the whole system crashed. And of course, what they were trying to type here was login, but I think there's a couple things that are interesting about this message. So the first message sent between computers in remote cities was low, like lo and behold, something's coming, something amazing just happened. And the other thing about this that's kind of interesting to me is this could be considered the first remote exploitable denial of service attack, because that G character, there was just something about that G character that just crashed the systems, right? So kind of a fun story. I enjoyed it, at least. And you know, I think it sets the stage for the fact that, like, all of what the internet is and is in all of what's been accomplished with the internet has involved a lot of cooperation. That cooperation takes place at internet exchanges like EuroIX and all of the other internet exchanges in the world. It takes place between peering coordinators that are setting up peering relationships between networks that seek to exchange traffic, private peering as well, and transit providers. And in all of these cases, the goal among all of them is to forward packets. I receive a packet in, my job is to get it out and get it closer to the destination. But of course, with DDoS attacks, some of that traffic that's being forwarded onto the destination is causing problems for the destination network. And one of the first steps in the internet community to develop collaborative ways to handle this, well, this is after the realization that everybody just updating ACLs via phone calls and emails didn't really work so well, or didn't scale very well, is to come up with this idea of remote triggered black holes. So this is a standards-based approach to handling DDoS attacks. And what it does, the way that you use this is you send a BGP advertisement of the victim IP to your upstream service providers. And the upstream service providers, when they see that advertisement, they agree to block traffic heading towards that destination. This does complete the attack. It takes the the victim offline, but it saves the network. It makes the network it removes the DDoS traffic from hitting the destination network and allows the network to survive the attack. So working on that model, one of the things that Team Cymru noticed in one of the large internet attacks that took place in the early 2010s was that there are some attacks that cause regional problems that are several hops away from the victim. And in these attacks, we have an infrastructure problem. We have an internet global problem with the fact that DDoS attacks can originate traffic from a diverse set of networks that might have different aggregation points along the path towards the victim, where those aggregation points themselves can suffer harm and have stability issues. And the global community at the time didn't really have a solution for how do you handle that issue, because this is a little bit of a different sort of thing. RTBH by the specification is not meant to be propagated to any peers. In fact, the specification says it must be handled as no export. So in 2014, we started this a service called Unwanted Traffic Removal Service. This is a no-cost community service. Right now, this slide is a little bit out of date. We've updated our peering sessions, and we've removed some that were not up. So that number is just that 1,500 BGP sessions is just a little bit off. But the underlying thing that represents is still true, that we have a very, very diverse set of network participants that when they receive when they hook up to the other system, the impact is quite apparent and easy to see. And the big difference between RTBH and others is that others is upstream of the attack and global. So instead of handling it by just pushing the RTBH rule to your upstream peer, we take that rule, we run some validation on it, and then we distribute that to the global network of others peers, all of whom have agreed to, when they receive that route, drop traffic destined for that victim IP. So in this case, what happens is we end up protecting both the internet and the victim. And the way that this works, or what the functionality within others that's present today, is we support IPv4 advertisements and IPv6 advertisements. And we have support for BGP advertisements as well as BGP flow spec support. And I'll talk a little bit more about the flow spec support in just a little while. But the core advantage to the flow spec is that you can send fine-grained block rules that do allow you to keep the victim online if the DDoS attack is targeting something other than the service port that the victim computer is performing services on. So for example, if you have a DNS amplification attack hitting a web server, the BGP flow spec rules will allow you to block that DNS amplification attack while still keeping the web server online. We've also now support /25s in IPv4 space and /49s in IPv6 space. This was a feature that was introduced because of the request of some of our participants that were suffering from what are known as carpet bombing attacks, where attacks were hitting a large swath of address space within their network. Previous to the current version of others, we only allowed /32s in IPv4 space, which didn't allow people enough flexibility to handle those carpet bombing attacks. But now we can. The way we do the validation is by looking at what routes exist in the global routing table. And we're verifying that the AS that's sending us a prefix is the origin AS for the most specific prefix. That covers the full validation method available within Utters v1, but Utters v2 is the current version we're on. And we've added RPKI support. Now, the use case here would be if somebody is using a third-party DDoS mitigation service provider, they could sign a ROA authorizing that service provider to advertise their address space. And when we see that ROA, we can validate against that ROA, understanding that the network owner that owns that prefix has an intention of having that other AS control traffic for that prefix. So adding that RPKI support enables the third-party DDoS mitigation providers to also leverage the system for infrastructure, internet infrastructure protection. So there's a saying that picture is worth 1,000 words. So let's go through and see what this looks like in practice. So during a normal sort of the way things normally look on the internet is you have something like this. You have a set of distributed clients that might be accessing a particular website that are connected over a number of different ASs, passing traffic towards the intended website. And once a DDoS attack happens, in this case, let's imagine this is a botnet based DDoS attack. A bot controller might send messages to a distinct set of or a distributed set of bots that then send attack traffic and knock over the web server. The other thing to note here is that in this image, all of these networks are also carrying all of that attack traffic. And what might happen then is any of them might also be subject to any sort of instability problems. The existing solution of RTBH might, depending on your network complexity and how widespread your network is, it might only be available to certain peers. But in this example, you can see that the effect of RTBH only blocks the traffic on the last path towards the victim. The rest of the attack traffic is still carried by a distinct set of networks across the world that are more than one hop away from the victim network. What others does is it introduces a different way of sending those advertisements, where we receive the advertisement from the victim and then we distribute it to all of our peers. And what that does is it takes the traffic further away from the victim network and blocks it at those ASs, sometimes getting all the way up to the network that's adjacent to the bots and to the attack traffic or the attackers themselves. And the result of that is that the internet itself is saved from having to transit that victim traffic. Now, the thing to remember about this is that the victim IP or the victim traffic that is being sent towards the victim, this is all wasted bandwidth and wasted traffic. This is wasted resources across every network that touches it, because the server is down, the network is not stable. So the blocking of the traffic upstream of the devices and closer towards the attacking devices brings about a situation where the entire internet benefits from this blocking structure. And it creates a situation where, through cooperation of the networks that are involved, the internet itself is more stable, and the internet itself can survive some attacks that might otherwise have caused problems. Now, I mentioned FlowSpec, and I know for some network operators, when I hear FlowSpec, they first thing that comes to mind is some horror stories about FlowSpec taking networks offline or causing device problems on some core routers or edge routers that they've heard about, or maybe they've experienced themselves. So I'm aware of those stories, and what I did is I sat down with some of my friends that are network architects at various networks, and some people that had a lot of experience testing the devices on how they scale with receiving FlowSpec announcements. And it turns out that most implementations suffer only when certain types of FlowSpec rules are sent, or received rather. And when we went through and listed out what those particular commands within FlowSpec were, we created a set, we excluded all of those, and then we created a set of rules that allows us to send what we are calling safe BGP flow spec routes. In the safe BGP flow spec, what we allow you to send is it must specify a destination CIDR address. It may specify an integer, integer only for the protocol field, the source port field, and the destination port field. Now, those that are familiar with FlowSpec will know that it allows you to also send ranges and arrays of integers for all three of these fields. But some routers, the way they implement that array expansion, it can cause some problems in efficiency. So we're restricting it to a single integer only. And then we require that you must set the action to drop, which in BGP FlowSpec space, it's traffic rate of 0. What this looks like after you think about the structure that we're allowing here, this looks pretty much like a very simple ACL that a router that you would all be familiar with on configuring routers. And in truth, that's really kind of what it is. And we all know that ACLs are pretty well about the most efficient thing that a router can do in terms of any sort of policy thing. So in most implementations, or all of the tested implementations that we've played with, this rule set is efficient to be processed on the devices. So it's not causing those problems that create the horror stories that we've all heard about BGP FlowSpec. And what this enables on a global scale with others is a fine-grained filter control that can push that filter closer and closer to the source of the traffic, thereby alleviating network congestion and network problems on any of the networks that might be carrying the traffic remote from the victim network. With solutions like this, there's always the question of, yeah, that sounds great and it's no cost, but does it really work? Well, on that, I have a story to tell. Let's see, it's been a little while now, about a year ago, a little less than a year ago, I was fortunate enough to work with a set of friends that was looking into and exploring a new DDoS vector. That vector was observed in the wild. And when we started to look at it and then start looking at the devices that executed this particular DDoS method, what we found was that this DDoS method was the biggest amplification vector ever discovered. With a single packet, you could cause a remote set of devices to generate 4.2 billion packets with one single UDP packet. And the traffic amplification, I can't recall it right off my head, but it's something like a multiplication factor of 250 million or something along those lines. Actually, that might be a little bit low. At any rate, it was a really big, scary problem. And one of the researchers that happened to be a others user and also happened to have a very, very well-connected network wanted to see, okay, if he sends this command to a set of devices, does it really work the way that it looked like to all of the researchers involved that it was working? So he launches a DDoS attack against his network, and the traffic starts coming in, and it starts cresting 100 gigabits per second, and then goes higher and goes higher and goes higher. And finally, he's like, okay, I cannot take this. So he sends a command to others to shut the traffic down. And others did. The truth is, like, it filtered enough of the attack that his network was able to stabilize, and he didn't suffer the harm from this attack. And it's interesting because, you know, this is a friend of mine. So when he told me about this, he used some really colorful language about like what this did for him. But the point here and the thing to take away from it is, in testing against the biggest amplification vector ever discovered, others stabilized a very fast, very well-connected network when they were getting into trouble and thinking that it well, regretting that he issued the command, maybe. So the honest truth is, others works. the technology is proven. It's been around since 2014. It's a great system that's already saved the day a number of times. And in my job as chief architect of community services, I oftentimes would ask myself, like, okay, so that's great. We've solved one problem. What other hard problems get easier when you can change just one slight element of the problem, and maybe instead of assuming that there's nobody out there to help you, you assume that maybe there's a community of operators that are willing to help. What else gets easier? Well, there's another service that we offer called Nimbus Threat Monitor. Now, this service is primarily aimed at protecting and cleaning up edge networks, but there is an element of cooperation in this service. The service is based on taking our IP reputation data, Team Cymru's commercially available IP reputation data that's best in class, and matching that against traffic that's traversing the edge networks that are Nimbus subscribers. With that service as well, we take the insights that we glean off of your device in your network about the threats hitting you, and that informs our entire cluster of Nimbus Threat Monitor participants by helping us to understand where are the bots communicating, where are the command and control servers sitting. And when we get that information, we share that back out. And we don't only share it to Nimbus Threat Monitor users, we also share it for free to the regional and national CSIRT teams throughout the world. And I'll talk a little bit more about that function later, but focusing more on NimbusTM and what it is. So it's an elk stack, as I said, and I'm going to focus on two different dashboards only, but I want to emphasize that this tool also does summarize network traffic. It does evaluations on the bandwidth flowing between ASs on your network, so that you can have a strategy on how to optimize your peering strategy. And it does base level network traffic graphs as well, so you can have an idea of what's flowing across your network as well. But today I'm going to focus really on the threat monitoring aspects of it, which are contained in the alerts dashboard and the compromised devices remediation list. So this is what it looks like under the hood, and this is a very busy page right now. And I when I took this screenshot, I had my screen zoomed out further than I thought. So apologies if this is a little bit hard to read, but going through what this looks like. This is the TC alerts dashboard, and in the upper right hand corner, you can see the different alert signatures with a count of flows and bytes and packets that are matching a number of different categories. Now, this network, the particular network that I'm showing the traffic from, just to mention, I do have permission from the network operator to show this. We would never show anything of any of our partners. In fact, part of the sign-up process is a mutual NDA. We would never show anything without explicit permission. We do have the permission in this case, but still, to protect this network, I've blurred things out. Now, I will also say that this network has been a participant for a little while in this system, so his network is fairly clean. And with the alert signatures that you see here, the number 1, number 2, and number 3 are scanner, honeypot, and brute force, which are kind of more scanning activity. They're not necessarily bots or anything like that, although any of this activity could be launched from a bot. But these are not these are, in some ways, you could consider them the more benign sort of activity in some cases. But he does have some Emotech controllers, some Mirai bots, and a Raccoon Stealer controller. With the rest of the graphs here, you can see some basic demographics and categorization of the traffic, including showing the top source IPs of all of the traffic that corresponds to talking to any threats that we've identified, and top destination IPs. And what this does is it allows you to visualize and see, like, oh, in this case, the top destination IP, I don't know what IP this is, but that's a pretty interesting demographic there. If you have one destination IP that's representing that much of your your attack traffic, that might be something to look at. A couple other things to highlight on this dashboard very quickly is we do have a histogram showing the alerts over time. And this, the thing that I like about this particular histogram is if you have a SOC center that has a SOC manager that decides that, hey, we've got a problem with Emotet and we want to clean up Emotet. You can, I'm getting a little ahead of myself, but you could come up with, you could filter on Emotet, and then the histogram will show the Emotet detection occurrence over time. The other thing to mention is there's a graph of the sum of flows. So this is like the relative chattiness of all of the different threats that are being detected on the network. And down at the bottom of the page, we have a raw event list of the events that we see corresponding to matching any of that traffic. I've blurred out and hidden the source and the destination IP, but on your own instances, those would be seen. And I have left the alert IP. The alert IP is the thing that we're detecting as bad. And I'm okay saying that our data shows that that these things are engaged in this activity. But at any rate, when you click on any of the entries, like here, I wanted to filter based on ASN. You can click on a particular AS and then click the plus sign and then create a filtered set. And the next page is the effect of that. So this one, I went through and clicked on that, and the entire dashboard updates with that filter added, showing only the traffic involved with that particular AS as an alert AS. Pardon me. What this allows you to do, and what the filters allow you to do in general, is to focus your efforts to understand the characteristics of the attacks that are hitting your network, and to divide oh no, I've got 440,000 alerts coming into my network, into a more understandable, digestible sort of format, so that when you issue tickets or you issue edicts to your SOC team and your SOC analysts, they have something to be able to work on versus just, hey, solve all the problems of the day. So through adding the filters, you could get kind of a more directed set of things, of targets to work on. And the other thing to mention is, all of the fields, those that are familiar with ELK dashboards might already know this, but all of the fields that you see are all able to very easily be turned into filters. And one of them most useful, I think, is to add a filter to the particular alert type. So this is the case where I was talking about a little bit earlier. A SOC manager might decide that, this week we want to focus on contacting our customers, or filtering our customers that are infected with Emotet or involved in possibly hosting an Emotet controller, as the case is here. You can just hover over that and then click the filter for this value, and then the updated list will show all of the same metrics, all of the same data points, but filtered only on the traffic that's tagged as communicating with Emotet controllers. And you can see here that these IPs are the ones that we are saying that our reputation data has confirmed are Emotet controllers. But you also have the same distribution data available for all of the particular network attributes for your own classification, for your own correlation, and for your own ability to find out how to remediate and control this as a threat vector. So that was a very terse and very quick introduction to the alerts panel. And the other panel that I want to emphasize here is taking that one step further. And the attempt here is to make it to kind of key on that idea of how do you create a remediation list or a target list for a SOC team to clean up threats. Within within the Nimbus product, there's also the remediation list, which we also call daily reports. And that data is a little bit more directed. These are threats where we've identified the address that we've identified being involved in malicious traffic resides on your network. So the source of the way to think about it is the source of the maliciousness is on your network. On this particular list, as I mentioned, this partner has been a partner for quite some time, and he has a relatively clean network. But even still, we have 8,000 IPs and 8,000 grades on devices in his network or on networks behind him that correspond to being flagged as being involved in malicious attacks themselves. The alert signatures here give you an indication of what the alert, what or how we're detecting it or what the alert reason was. Within the Nimbus product as well, there's a definition list. So there's a dictionary of what does darknet mean. But I'll tell you that one of the set of sensors that Team Cymru runs is a large network, a large empty network where we're looking for any sort of packet coming into that network, because any network that's not offering any service, if it's receiving packets, there's something wrong potentially with the sender of that packet. So that detection method is saying that is being used here to identify multiple hosts on this network, saying that they're sending packets, spurious packets to network blocks that don't have any services at all running on them. Then at the bottom here, you'll see that there's some proxy data. The proxy data is identification and tagging that there's this proxy running on your network. So the IP addresses that are over in these fields here, they are acting as proxies, as open proxies for the internet. Now, depending on your network policies, that might be a problem. That might not be a problem. It depends on your network policy. But in this list as well, you can actually add filters as well. So you could filter out proxies if your network policy is that, well, you know what, we're a service provider and we let people run proxies. But for a lot of other networks, especially corporations and enterprise networks, something like an open proxy running on your network might be something you want to pay attention to. There's a number of other alert signatures that aren't shown on this in this example. Unfortunately, it was hard to get a cluster where it showed a plurality of different signature types. But at any rate, any of the alert signatures that we have would appear in this list, and this would allow you to have kind of a punch list of IPs and devices to reach out to, or customers to reach out to figure out how to remediate that problem. Or depending on your network, if you're more a corporation or enterprise, then now you have a punch list of devices to go and get cleaned up when you have the available time to do so. So that was a quick introduction to the Nimbus product. This again is a no-cost service that any network out there can sign up for, and we would encourage you to do so. And right before the presentation, I was chatting with the organizers, and I had thought that I had a little bit less time for this than I did. So my apologies here. I created a very, very terse slide here, and I could have gone a little bit more. So this is not a very pretty slide, but let me go through some of our other community services just to give a very brief overview. And then of course we can have some time at the end for questions if you have any. One service that we offer, and we've been doing this for years and years, and I really strongly consider or recommend that you all sign up for this. We run a mailing list called Dragon News Bites, and this is a hand-curated list of what we have seen in the various InfoSec news channels that we monitor and various different blogs that we monitor. These are the stories that you want to be aware of. This is it's between about like 7 and 10 stories per day, where what we do is we summarize the story and pull out about a 2-paragraph or so excerpt and we send that on to you. And I'll be honest, I've been in InfoSec for quite some time here, and I hands down recommend the people that we have that are curating this. I don't know how they do it, but they seem to always find the right stories to include. This list has I want to say it's close to 7,000 subscribers, and that's a plurality of people in different various different roles, from security engineers all the way up to CISOs, and then also like policy and governance and government agencies, and a wide swath of internet experts around the world. The other thing that's an advantage to this, and I should have included this on the list, but I didn't, is Team Cymru runs 4 conferences per year. And if you are on these lists, you'll get the notices about those conferences. Our conferences, just to mention it, I'm a little biased, but our conferences are the best in the world. I'll just go out and say that. They're vetted TLP Red conferences, where we hold again 4 per year, and you'll get some of the best InfoSec presentations that you'll ever see. We focus on case studies, where we have, sometimes active law enforcement that are investigating cases come and present on their cases, or we have DFIR teams or threat analysts coming in presenting on their cutting edge research that are unmasking both the techniques that attackers are using, as well as the infrastructure attackers are using, and sometimes even who the attackers are, the people behind it, and just very excellent content. But I guess before I get off of events, let me mention just a couple things there. So I mentioned there's 4 per year. There's 3 that are of a particular format called RISE, where that stands for Regional Internet Security Event. And these conferences are ones where we go to where you are. One of the things we found is we've been running our flagship conference, Underground Economy, for many years, but it's difficult for certain people to be able to travel to where the major conferences are. The Underground Economy conference is about 400 to 500 people per year, and it represents about 85 or more countries every time we run it. That event takes place somewhere in Europe every year. We've been in Strasbourg for a number of years. This coming year, the main facility that we've used in the past is being renovated, so we're still working on the final details of where it will occur. But the RISE events, these are a similar format to the Underground Economy, except that we bring the conference to you. They're a little bit smaller. They tend to be maybe about 150 to 250 people. The last one we ran was in Bangladesh. Or wait, did I skip one? I think I might have skipped one. But at any rate, the next one that we're running is in Albuquerque, New Mexico in the US, and that's coming up this coming week. And then after that, the next one is going to be in Mexico. And sorry if I stole the announcement there, but the next one's coming up in May in Mexico. So we go around the world. We've been in Asia many times. We've been in Africa many times, South America many times, and more recently we're going a little bit to North America too. But we also have been to Europe many times, so we go all over the place. And the advantage there is, the internet, like I mentioned, is a collaborative cooperation of network providers around the world. And sometimes it's hard for them to travel, so we've got to go to them when we can. Our Bogon reference is one of our longest running community services. Some people in the networking industry know Team Cymru as the Bogon guys. The Bogons, of course, are network address space that should not appear on the internet. And what we do is we run a service where we curate the list from the regional RARs to pull all of the data on what address blocks are either special allocation or reserved or otherwise special use, pull all those together, create lists, and offer BGP peering sessions where we send those that address space to you so that you can block that at your perimeter. Our IP to ASN service is a service where you pass it an IP address or a CIDR block, and we will pull the data from our visibility into global routing tables and tell you what the originating network that's advertising that, the most specific covering prefixes for that particular address are. So this is quite useful for categorizing things like the source networks that are sending traffic to you, or that you might be sending traffic to, in a very quick and easy and lightweight API sort of way. Our malware hash registry is a similar thing, similar sort of function to IP to ASN. You pass it something and it looks it up. Behind the scenes, Team Cymru processes somewhere around 300,000 malware samples per day, plus or minus hundreds of thousands. It fluctuates, even gets above 500,000 on certain days, where we find different, or we run those through a variety of sandboxes. Then we offer this service for free, where if you pass a hash of a binary that you see to the service, we'll return our hit rate that we've in our detection rate via a very lightweight interface to the back to you. So you get the benefit of our sandboxing efforts and our malware detection efforts by just passing the hash that you detect. One of the common ways that this service is implemented is via Milter rules. So mail exchangers are some people have implemented it so that mail exchangers are taking the attachments that they have incoming, hashing them, and then checking them against our service before they pass the mail on to their recipients. And I alluded to the CSIRT assistance program a little bit earlier when I was saying that the Nimbus product helps other networks. So the CSIRT assistance program is a program that's restricted to only regional and national CERT teams for membership. And we have, I believe it's 145, it might be 146 different regional and national CERT teams that are benefits of this program right now. We offer free threat intelligence to them. We take our best data and we give them the detections that we see within the address space that they have a remit to protect. This we offer as all of the services that I've talked about here. All of these services are free services, and part of that is just the reason that they're free services is that cooperative element means that securing the internet is all of our responsibilities. None of us individually can secure the entire internet, and as part of that, we're working with whomever we can partner with to make sure that that goal of securing the internet and cleaning up the internet is accomplished. The CSIRT assistance program is a natural way for us to work with the people that can remediate threats at different national and regional levels to help accomplish that goal of cleaning up the internet. So going back to that question that I posed earlier, what other hard problems get easier when the community of operators cooperate? If there's one takeaway other than sign up for all of the free services and use our free services, I would encourage everybody to think about this question a little bit, because there are a number of problems that when you start thinking like, hey, maybe I can reach out to my friends and maybe they can reach out to theirs, the hardness of the problem goes away. And there's some interesting solutions in that space that can help to solve worldwide internet infrastructure problems. And if you have any ideas or thoughts in that regard, we always love to hear from you. And if you do, please just drop us a note at outreach@cymru.com. We'd love to talk to you about what you're seeing and what you would like us to be involved in helping to solve. With that, thank you so much. I appreciate you listening. And are there any questions for me?
Thank you, James, for that good talk. We do have a question, it looks like.
James, just a quick one. I'm
Yep.
particularly interested in how UTRS scores the reliability of provider reported malicious traffic. Do you screen this at all? Do any sanity checks?
Yeah, that's a great question. So we don't screen the addresses to determine whether they're attacked or not. We rely on the network operator to only send addresses that they decide are being attacked, because the validation that we do, we validate that the address that we are receiving is being originated by the person we receive it from, or is RPKI delegated to the person we receive it from. Okay. So we're putting that burden of saying that, you know, this address needs to be blocked to the network operator that owns that address space.
But in this case, the attacking IP would not necessarily be the person reporting that it's being attacked, obviously.
Yeah, and you cannot send the attacking IP. You can only send the victim IP.
Right. Okay. So effectively, what you're saying is you pick up from NetFlow what is actually whether you can confirm what you see is the same. That's basically what you're saying, is right?
No, we're not using NetFlow analytics for the UTRS product at all. The UTRS product is based only on BGP tables and RPKI data for the validation, because what we're looking for during that validation is if you are sending me a prefix, are you an authorized owner, or are you authorized by the owner of that prefix to assign policy to that address? That's what we're looking for.
Okay. I'm just thinking about how it could be abused. That's all.
Yeah, no, I understand that. That's why the validation steps are in there, because in the case of if your AS is advertising an address or a prefix rather, and you send us an address within that prefix, if you are an attacker attacking that and you are also originating it, then you could just drop the advertisement. So you already have the full control over that network prefix space. So this doesn't increase an attack surface in any way, because we're making sure that the person that we're receiving it from is duly authorized to send it, right?
Okay.
Thanks, Rupert. I see there is one question in the chat, and that is, are there any plans to make UTRS BGP sessions more stable?
Interesting. So I have not heard of or know of any reports of instability with the BGP sessions. So if that's something you are experiencing, Radu, please send an email to support@cymru.com and we'll take a look at that. I will say that one of the other differences I didn't really mention with UTRS version 1 and version 2 is with UTRS version 2, we now have some geographically dispersed routers for redundancy. So one option might be to peer with a router that might be a little closer to you, but please do send an email into support@cymru.com, and we'd love to hear what you're seeing so we can get that resolved.
Thank you. Are there any questions and comments for James? Radu's just replied and said thank you.
Thank you.
He'll be in touch. All right, then in that case, I would like to say thank you, James, and to Team Cymru for your support and time for today's session. It was very, very interesting talk, so thank you again. And hopefully we'll see you around next time. Thanks, everyone.